So how can we find the indefinite integral of x times e raised to the x? To do this, we need to use something called integration by parts. The integral of u dv is equal to u times v minus the integral of v du. So we need to determine u, dv, v, and u, and du. Let me put it in a different order. So which one should we set equal to u and which one should we set equal to dv? It's best to set u equal to x, because if we do so, du will simply be equal to 1 times dx. And when dealing with constants, they're a lot easier to integrate than variables. So we're going to make dv equal to e to the x dx. Now v is the integral of dv. The integral of e to the x is simply e to the x. So now using the formula, u times v, that's going to be x times e raised to the x minus the integral of v du. V is e to the x, du is 1 dx. And the integral of e to the x is e to the x plus some constant c. So this is the final answer. That's the integral of x raised to the, or x times e raised to the x. Let's try another problem. Let's integrate x times sine x dx. So what should we make u and dv equal to? So just like before, I'm going to make u equal to x. So that du is going to be 1 dx. Now dv has to be what remains, sine x dx. Now what is the integral of sine? The derivative of what function will give a sine? The integral of sine is negative cosine. The derivative of negative cosine is positive sine. So using the formula, the integral of u dv is equal to u times v minus the integral of v du. So u is x, v is negative cosine x, and then minus v, and du is 1 dx. So far we have negative x, cosine x, and then these two negative signs will become positive, so plus the integral of cosine x dx. Now the antiderivative of positive cosine is positive sine. So the final answer is what you see here. Negative x cosine x plus sine x plus c. Now here's another problem to work on. Let's integrate x squared ln x. So what should we make u and dv equal to in this problem? If we make u equal to x squared and we make dv equal to ln x dx, the integral of ln x will be quite difficult to do unless you know what it is, so we're not going to do that. So it's best to make dv x squared dx, and u is going to be ln x because we know the derivative of ln x. The derivative of ln x is 1 over x. And the antiderivative of x squared, the antiderivative of dv will give us v. So the antiderivative of x squared dx is x cubed over 3. So let's use the formula now. U times v, that's going to be ln x times x cubed over 3 minus the integral of v times du, and du is 1 over x. It's supposed to be dx. So this is equal to 1/3 x cubed times ln x. And then we could cancel an x. And so we have minus 1/3 the integral of x squared dx. The integral of x squared is going to be x to the third over 3, and then plus some constant c. So the final answer is 1/3 x cubed ln x minus 1 over 9 x to the third plus c. And that concludes this problem. So let's work on some more examples. Let's try this problem. What is the antiderivative of the natural log of x? How can we use integration by parts to get this answer? Now we can't make u equal, well, we can't make dv equal to ln x because we don't know the integral of ln x. We're trying to figure that out. So therefore we have to make u equal to ln x. The derivative of that is 1 over x dx. dv has to be just, we can make dv dx if we want to, or 1 dx. And so v, the integral of 1 dx, is just x. So now let's start with the formula. And so it's going to be u times v. U is ln x, and v is x, minus the integral of v, and then du is 1 over x dx. So far we have x, ln x, x times 1 over x. The x variables cancel, so we have the integral of 1 dx. Now, the integral of 1 dx is x. So this is the final answer. X ln x minus x plus c. That is the integral of the natural log of x. Let's find the indefinite integral of x squared sine x dx. So which part should be u and which part is going to be dv? We need to make u equal to x squared, and we need to differentiate it twice to bring it down to a constant. So this is one of those problems where you have to use integration by parts 2 times. Du is going to be 2x dx. dv is sine x dx. So this is dv, and this is going to be u. The integral of sine is negative cosine. So let's start with the formula. So u times v, that's x squared times negative cosine x, minus the integral of v, which is negative cosine x, times du, that's 2x dx. So let's organize what we have. Negative x squared cosine x, and then these two negative signs will become positive, so positive the integral of 2x cosine x. We could take the 2 and move it to the front, so it's just going to be x cosine x. Now, we need to use the integration by parts formula on the integral of x cosine x. We're going to make u equal to x, and dv is going to be cosine x dx. The integral of cosine is sine, and the derivative of x is 1 dx. So using the formula, it's going to be u times v, which is x times sine x, minus the integral of v du. So v is sine x, du is just dx. And so the integral of sine is negative cosine, and then plus c. So now what we need to do is replace this part with what we have here. So it's going to be plus, we need to distribute 2 to everything in here. So it's going to be 2x sine x plus, this would be plus cosine x, but times 2, so plus 2 cosine x. And we don't need to multiply c by 2 because c is just some generic constant. And this whole thing is equal to the original integral. And so this is the answer. Negative x squared cosine x plus 2x sine x plus 2 cosine x plus c. Now let's work on this problem. Let's say we have the integral of x squared e to the x dx. Go ahead and try that problem. So let's begin by writing the formula. The integral of u dv is equal to u times v minus the integral of v du. Now what should we make u equal to? And what should be dv? I would prefer making dv e to the x dx, because once we integrate it, it's going to stay the same. And I want x squared to eventually become a constant. So this is one of those problems where you need to use the integration by parts formula twice. So we're going to make u equal to x squared. du is going to be 2x dx. So using the formula, it's going to be uv. That's going to be x squared. That's u. V is e to the x minus the integral of v, which is e to the x, times du. That's 2x dx. So now this becomes, well, before we do that, let's use integration by parts one more time. So I'm going to make u equal to 2x. du is going to be the derivative of 2x, which is 2, but times dx. dv, we're going to make that equal to ex dx, just like we did before. And the integral of that is simply ex. So we're going to have x squared ex, and then minus. Now let's use the formula again for this part. So it's uv, so 2x e to the x, and then minus the integral of v du. So that's 2 e to the x dx. We're multiplying those two. Now let's begin by distributing the negative signs. So this is going to be negative 2x e to the x, and then these two negatives will cancel, giving us positive, well, let's take out the 2. So positive 2 integral e to the x dx. So our final answer is going to be x squared e to the x minus 2x e to the x. Antiderivative of e to the x is just e to the x, and then plus c. Now if we want to, we can factor out e to the x. So we're going to have x squared minus 2x plus 2, and then plus the constant c. So this right here is our final answer. That is the antiderivative of x squared e to the x. What about this problem? What is the integral of ln x squared dx? Try that. So for this problem, what we need to do is we need to make u equal to ln x squared. dv is going to be equal to the other part. We're going to make dv equal to dx. So v is going to be the integral of dx, which is x. du, I'm going to write that here. I need more space. We need to use the chain rule. So first let's use the power rule by moving the 2 to the front. So it's going to be 2, and then we'll keep everything on the inside the same. 2 times ln x, and then we're going to subtract that by 1, and then take the derivative of the inside. The derivative of ln x is 1 over x. So using the formula, this is going to be u times v. So v is x, u is ln x squared, minus the integral of v du. v is x, du is 2 ln x times 1 over x, and then let's not forget the dx part. So we could cancel x and 1 over x. So this becomes x ln x squared, and then we could take out the 2. We can move it to the front, so minus 2 integral ln x dx. Earlier in this video, we determined that the integral of ln x is x ln x minus x. So this is going to be minus 2, and then we can replace this with x ln x minus x. Now let's go ahead and distribute the 2. So our final answer is going to be x times ln x squared minus 2x ln x, and then negative 2 times negative x, that's going to be positive 2x, and then plus c. So this is the indefinite integral of ln x squared. Now, what would you do if you were to see a problem like this? ln x to the 7th power dx. Go ahead and try that. Well, first, you need to realize that we can rewrite this problem. A property of logs allows us to move the exponent to the front. So make sure you understand this. This is not ln x to the 7th power like this. If it was, we can't move the 7. The 7 is only affecting the x variable. As a result, we can move the 7 to the front. So this becomes 7 ln x. So this is what we're integrating. This is equivalent to 7 integral ln x dx. And we know the antiderivative of ln x. It's x ln x minus x. So this is our final answer. It's just 7x ln x minus 7x plus c. Now, let's try this one. Let's find the indefinite integral of e raised to the x sine x dx. Go ahead and work on that. So for this problem, I want to make u equal to sine x, and then dv, I'm going to set that equal to e to the x dx. So v is simply going to be e to the x. du is the derivative of sine x, which is cosine x. So using the formula, it's going to be uv, that's going to be e sine x minus the integral of v du. So v is e to the x, du is cosine x dx. So we need to use integration by parts one more time. But this time we're going to make u equal to cosine x instead of sine. And dv is going to be the same. dv is going to be e to the x dx. And v is the same. du is going to be the derivative of cosine, which is negative sine, and then times dx. So now we're going to have ex sine x minus, and then in brackets, uv, so that's going to be ex cosine x minus the integral of v du. So v is e to the x, du is negative sine x, and then dx. So let's go ahead and distribute the negative sign. I'm going to rewrite the original integral. So the integral of ex sine x, that's going to be e to the x sine x. These two negative signs will become positive. And then we need to distribute this negative. So it's negative e raised to the x cosine x. And then we need to apply the negative to this, which is going to be negative e to the x sine x. Now the key to solving this problem is to realize that this term is very similar to the original problem. So what we want to do is we want to add this to both sides. If we move it to the other side, we're going to have 2 ex sine x. Which is equal to this. Now we want to find the value of just one integral e to the x sine x. So what we need to do is divide both sides by 2. So that's, we could say that our final answer is 1/2. We can also factor out e to the x. So it's 1/2 e to the x, and then times sine x minus cosine x plus c. So that's the antiderivative of e raised to the x times sine x. Now let's move on to our next example. Let's find the antiderivative of ln x squared divided by x dx. So go ahead and try that. Now the first thing that I want to do is I want to rewrite this as ln x squared times 1 over x dx. I want to multiply it as a product of two functions. Now what I'm going to do is I'm going to make u equal to ln x squared. Du will be 2 times ln x to the first power times 1 over x, and then dx. So since I made u ln x squared, dv is going to be the other part. dv is going to be 1 over x dx. So antiderivative of 1 over x is ln x. Now using the formula, this is going to be u times v. U is ln x squared. V is just ln x minus the integral of v du. So v is ln x. Du is 2 ln x times 1 over x dx. So let's put this all together. So first I'm going to rewrite the original problem. That's equal to ln x squared times ln x, that's ln x raised to the third power. And this 2 I'm going to move to the front. Here we have ln x times ln x, that's ln x squared. And it's multiplied by 1 over x, which we can move that to the bottom. And we need to realize that these two terms are similar. So we need to add this to both sides. Or if we move it to the other side, we'll basically add in 1 plus 2, which will become 3. So on the left side, we're going to have 3 integral ln x squared over x dx. And that's going to equal ln x to the third power. So if we divide both sides by 3, This 3 will disappear, and we're going to have it underneath here. And then plus our constant c. So this is the answer to the original problem. That's how we can find the integral of ln x squared over x. Now for the sake of practice, go ahead and try this. Find the indefinite integral of e to the 3x cosine 4x dx. So whenever you have an e to the x times a sine or cosine, it's good to make the cosine part equal to u. That's what I'd like to do personally. So in this one, I'm going to make u equal to cosine 4x du. The derivative of cosine is going to be negative sine 4x, and then times the derivative of the angle. The derivative of 4x is 4. And then we're going to have times dx. So dv in this problem is going to be e to the 3x dx. The antiderivative of e to the 3x, it's e to the 3x over 3, which we can write as 1/3 e to the 3x. So using the formula, it's going to be uv, so that's 1/3 e to the 3x times cosine 4x minus the integral of v du. So v is 1/3 e to the 3x, du, that's negative 4 sine 4x dx. So what we're going to do now is we're going to move the constants to the front. The two negative signs will cancel. They will become positive. And we can move 1/3 times 4 to the front. So this is going to be plus 4 over 3 integral e to the 3x sine 4x dx. Now we need to use integration by parts one more time. So dv will be the same. We don't need to adjust this part of the formula. But u is going to be sine 4x as opposed to cosine 4x. So du is going to change as well. The derivative of sine is cosine 4x, and then times 4 times dx. So using integration by parts, we're going to have u times v. So that's 1/3 e to the 3x times sine 4x, and then minus the integral of v du. So v is 1/3 e to the 3x, and then du, that's times 4 cosine 4x dx. Now let's go ahead and distribute 4 over 3. So multiplying those together, that's going to be 4 over 9 e to the 3x sine 4x. And then this 2 will also be 4 over 9, but it's going to be negative 4 over 9. Actually, there's a 4 here. So this is 4/3 times 4/3. So that's 16 over 9 with a negative sign. And then we're going to have the integral of e to the 3x cosine 4x dx. Now notice that these two are similar. So we're going to add 16 over 9 integral e to the 3x cosine 4x dx to both sides. So this is 1, but we can treat it as if it's 9 over 9, just to get common denominators. So 9 over 9 plus 16 over 9, that's going to be 25 over 9 integral e to the 3x cosine 4x dx. And then that's going to be 1/3 e to the 3x cosine 4x. And then plus 4 over 9 e to the 3x sine 4x. Now, to get this to 1, what we're going to do is we're going to multiply both sides by the reciprocal of 25 over 9. So that is by 9 over 25. So those two fractions will cancel. On the left side, we're just going to have e to the 3x cosine 4x dx. And what I'm going to do, I want to keep this in factored form. So we have 9 over 25. From 1/3 and 4 over 9, we can factor out a 1/3. And we can also factor out e to the 3x. So here we took out e to the 3x. We're left with just cosine 4x. Here we took out e to the 3x, and we took out 1/3 from 4 over 9. So we're going to have 4/3 left over times sine 4x. The last thing we could do is maybe reduce this. So if we divide both numbers by 3, this becomes 3 over 25 e to the 3x, and then times cosine 4x plus 4 over 3 sine 4x plus c. So that's going to be the answer for this problem. That's the indefinite integral of e to the 3x cosine 4x.